In this particular video, we're going to be covering the concepts of atomic structure and the size of atoms and electron configurations as well. So those are the topics that we're going to be covering in this particular video. We have the following question. We've got three elements here, and what we have is listed their respective atomic radius in picometers. Sodium has an atomic radius of 186. Magnesium has an atomic radius of 160, and potassium has an atomic radius of 227. So the question they're asking is, in terms of atomic structure, explain why the atomic radius of magnesium is smaller than the atomic radius of sodium. So we've got two different elements that we're talking about here. So sodium has the electron configuration 1s2, 2s2, 2p6, 3s1. Magnesium has the electron configuration 1s2, 2s2, 2p6, 3s2. So now, why is the atomic radius of magnesium smaller than sodium? Well, let's take a look at what we have over here. So magnesium has one more proton and one more electron than sodium. So that's the first thing. So we're talking about element number 11 as far as sodium is concerned, element number 12 as far as magnesium is concerned. So both have electrons in the 3s orbital. Magnesium has 2 and sodium has 1. So now, since we have one more proton in magnesium has the higher effective nuclear charge. So since it has a higher effective nuclear charge, it attracts the electrons, holds them more dearly, and therefore, since it holds them more dearly, it brings them closer to the nucleus, so that means that the radius becomes smaller because the electrons are closer to the nucleus. So therefore you have a smaller radius. In B, we're comparing K, potassium, and Na, sodium. So if I write the electron configuration for these using abbreviated notation, using noble gas configurations, potassium has the argon configuration, 4s1. Sodium has the neon configuration, 3s1. So common sense should dictate that when you increase the principal quantum number, obviously you're increasing the number of shells. The shells get farther and farther away from the nucleus the higher the principal quantum number. So 4s orbital is further from the nucleus. Than the 3s. So therefore, it has the larger radius. Concurrent with that is that it has the larger diameter too, okay, because the diameter is equal to 2 times the radius. So basically what we've done here is we've basically taken a look at atomic structure, and we've studied the size of different types of atoms, looked at the electron configuration, and made a few common sense judgments as far as principal quantum numbers are concerned. The higher the principal quantum number, obviously, the bigger the radius, the particular shell that you're talking about is further away from the nucleus.